This question is from GATE 2016 Mechanical Engineering paper set 2, question number 32. A rigid horizontal rod of length 2L is fixed to a circular cylinder of radius r, as shown in the figure. Vertical forces of magnitude P are applied at two ends as shown in the figure. The shear modulus for the cylinder is G and the Young's modulus is E. The vertical deflection at point A is, we need to find out the vertical deflection at this point, that is point A. Let's see how forces P affects the cylinder. Now these forces P upward and P downward on the ends of the bar will subject the shaft to a torque in clockwise direction because P is upward on this side and P is downward on this side. We have in turn a clockwise torque being acted upon the shaft. And this torque value will be P into L. If we calculate the rotation of the shaft, we will be able to calculate the deflection at point A just by taking a linear relationship between deflection at this point, let this point be C, and point A. Because it will be linearly varying, bar will remain straight. Remember, this bar is not bending, it only rotates, as is the section of the shaft rotating. We have torque on the shaft as P into L from this side and P into L from this side. So it is 2PL. Torque is 2PL. For finding out rotation, let's use the pure bending equation. We have T by J is equal to G theta by L is equal to tau by R. Only the first two terms are required for us. We need to find theta. So rearranging, we get TL by GJ. Length of the shaft is also L. And half length of the bar is also L. So keep that in mind. Torque is 2PL. Length is L divided by G is given to be G itself. And J here is the polar moment of inertia. So polar moment of inertia for the shaft cross section in terms of radius R will be pi by 2 into radius raised to 4 into R raised to 4. Solving for this, we get theta as 4 times PL square divided by pi g R raised to 4. Now, this theta is nothing but the angular deformation of the shaft, right? To this shaft, there is a rod attached. So, when the shaft rotates by a certain angle, this rod will also rotate by the same angle, that is theta. We know the angle theta. Let it be a very small if this is a very small deformation, we can find out the deflection. Let this deflection at point A be delta A. Length is half length of bar is L. So we can find out delta A to be angle theta into L for small values of theta. So finally we have deflection at point A to be 4P L square into L gives us L cube divided by pi g R raised to 4. Let's mark the correct option. We have vertical deflection at point A is option D, 4PL cube by pi g R raised to 4. To learn about torsion on shafts in detail, you can refer to the NPTEL video, lecture 18, torsion 1 from the course lecture series on strength of materials. It's by Professor S.K. Bhattacharya. He's from Department of Civil Engineering, IIT Kharagpur. I hope this solution will help you clear your doubt. Thank you.